There. Okay. Hey. Projector on. Just unplug it, plug it back in, I guess. Uh-oh.
I think before you are asleep.
No bueno. Okay.
I'm sitting
Let's
here.
see here. My laptop likes it, but yeah, I'm gonna do one this week, and then so quiz 3 to wrap it up, and then but I'll give you longer to finish it, so it won't be like a weekend thing. It'll be, I don't know, till whenever. Okay. Could even be till the 25th.
They're gonna be like the last one?
Yeah, just theory. Yeah. Yeah, it'll be just theory.
Time-wise, right?
Yeah, it'll be just theory on hypothesis testing, confidence intervals, and a little bit of regression. So just theory. But yeah, I want to give you guys lots of time to do it. Obviously, once you start, then you're in it. But don't want to put too much pressure on. I don't know what to do here. It is not projecting. Unplug it again. Maybe. Oh, maybe that one. Okay. Can you guys all join in on the Zoom room? You guys can cozy up. Because I'm sharing my screen in the Zoom room. It's just not sharing here, which is very annoying. Let me try unplugging it. Projector off.
Recording in progress.
In like Flynn, okay. Oh. Yeah, you see my screen, right? Yeah. I'll try to get this going, but until then, you guys can share a screen. Ideally, if you have the Excel sheet open, we can work together. That's okay. That's okay.
The first mini presentation is going to be 10%. So
yeah. Okay. Yeah. Well, I think it's in Kentucky, so yeah. Time to move to Kentucky. I guess. I'm confusing because I keep wanting to touch my iPad and change the Excel, but I can't. It doesn't work like that. Still trying to get it, but okay. You've got the data set. We've got information on the prices of homes, so the selling price of homes, how many baths they have, so how many bathrooms, what the square footage is, and what the number of bedrooms are. So I find that really annoying. Why is it? Come on. Anyways, so the goal with regression is usually to make predictions, right? And so in this case, we could argue that, you know, we want to predict how many bathrooms there are given some selling price or some square footage or some number of bedrooms. But usually the thing that we're interested in is the selling price. Obviously, we want to predict the selling price with some aspects. Now, last week we introduced just simple linear regression, and simple linear regression just means that there's only one predictor, right? So one value of X. Okay? And so if I type it in here, y hat is b0 plus b1x is the model for a simple linear regression. Simple regression. Oops. Yeah. Whereas now we want to try to incorporate a couple of other predictors, right? And so simple linear regression just means that there's only one predictor or one value of X. Okay. Whereas if we go for multiple regression, we have y hat is going to be, there's some intercept still, right? We need some anchor on this thing. It's going to become difficult to kind of visualize or at least imagine what it looks like, just because once we move past two predictors, right? Two predictors would be 3D, and then 4 predictors, our brains don't do that, right? And so, but we can, in theory, have some b1 x1 plus b2 x2 plus b3 x3. I think I used, okay. So now here we have 3 predictors. Obviously, the more information that you incorporate into your model, right, the better your prediction is, right? And so what we're going to do today is we're going to play around with this data set and build a model incorporating these 3, the baths. Can you see my pointer? I can't see. Okay. I have to check on here to see what you guys see. And so, yeah, weird situation. Right, so our selling prices are Y. So Y is our selling price. And we want to predict the selling price given some inputs. Okay. And if you've worked through the one of the exercises, the simple linear regression exercise from last week, which you may not have, I'm assuming you haven't, that's okay. I'll show you it now. First thing we want to do is, I guess, in the question, we want to look at the scatter plots of the selling price versus the number of bathrooms, the selling price versus square footage, and the selling price versus the number of bedrooms. Yeah. So first I'm going to do that. Insert. And I feel like it likes X and then Y, but maybe I'll just try it like this and see what happens. Insert a scatter plot. Yeah, so they're reverse. Gonna try to make it bigger. Whee. So that's a problem, right? Because it likes to have the X variable as the first column and the Y variable as the second column. So what you have to do is you have to rearrange things. Now, what I like to do when I'm working with a data set like this is, yeah, I want to delete that, is I make a copy. So from here, I'm just going to add a new sheet and call it reorganized for spreadsheets. Oops, that's not what I meant. Scatter plots in a spreadsheet, I guess, so. Doesn't like to cut, paste, delete. Doesn't like it. There. So now my Y is the last variable, and then I can play around with my X variable. So now it should work. X and Y, insert a scatter plot. Nice. Just so I can keep track here, I'm going to format axis. How do I add an axis label? Add chart elements. Yeah, right? Here. This was baths. Just to keep track of what they are. And close this and zoom in. So if we were just interested, and I should add a label on the y-axis, but I haven't. I just need to keep track of which explanatory variable I have or which predictor. And so to just fit a model to predict selling price from the number of baths, what do? You can click one of the dots and they should kind of highlight and say that that's where you are. And if you add a trend line, if you right click, add a trend line, then it'll give you some options. So we're going to work with a linear model just because that's our go-to. If you click on if you do the exponential or the logarithmic model, which I suspect that you would do sometimes, because I know that Allison works with log graphs and stuff like that. So maybe you would do logarithmic. All that does for you is it does the transformation for you. And so kind of fun to play around with, but we're going to focus on the linear model. Now down here at the bottom, you have the option to display the equation on the chart and also display the R² value on the chart. And you can move those around, make them more visible. And now you have your model. Another way that we could find this model, so this is the easiest way to find the model for a single predictor, right? Like we said, if you have multiple predictors, then it's really hard to craft that in one graph because we can't do that. And so another way that we could do it is if you go to your data tab, there's the data analysis tool pack, which is not to be confused with the analyze data in the home tab. That's different. I don't know why. I can't explain it. The analyze data is kind of a new thing, and it is cool for kind of quick analyses. But if you go to the data tab, there's the data analysis tool pack. You might have to install it once. Did I make you do it already? I feel like I did, yeah. So you should have this data analysis tool pack, And one of the options is regression, which is what we're doing. That's nice. Oh, I was playing around with this before. So we're going to input the Y range, which is the selling price, and shift down. And for us, right now, I just want the baths. So I'm going to go click on the top one, Command Shift down, it highlights the rest. I've also told it that there are labels because I included the labels of the variables. And then all the other defaults are fine. So if you're working with residual plots, you can ask for the residuals and things like that, but we're not going to worry about that. So once we do this, let me zoom in. That's the way. Okay. We get all this output here. And let me just confirm with our scatter plot copy. Can I put it here? Oops. Paste. Pasted over some stuff, didn't I? Naughty, naughty. There. I'm gonna put this over here to show you where everything came from. I'm trying to get it all on the same screen. So we get all this output. A lot of it you can ignore. We're not going that deep into the theory, right? We're just going to be able to do things just enough to be dangerous, as they say. But that's okay. Here, we're given the R squared 0.2053. I'm going to highlight that. All right. And we get the ANOVA output, which you don't have to worry about. And then what we want are these coefficients. Oops, come on. I'll highlight these two. Okay. So you've got your intercept, which is your y-intercept, right? Notice how it's written differently in the model. We've got mx plus b in that format. Of course, whatever's attached to the x is the slope. And so then once we kind of get that sorted, right, the model is has a y-intercept of 168,347, turns out 0.351, right? But it's shortened it for us. And then the slope, right? So the coefficient for the baths is 57,704 and 64 pennies, which they've rounded to $5. That's fine. And so from here, right, our y hat is going to be, let's see, how can I write this? I want to put it here. Is going to be the y-intercept 168,347.35. I'm going to go to 2 decimal places just because it's money, so that's fine. 2 is good. Plus 57704.64 pennies times the number of baths. Right. Making sure that you multiply the slope by the number of baths, right? So now the y hat, I could replace it with the predicted price is going to take the number of baths and then predict the price, right? And so last week we talked about how to interpret the slope, how to interpret the intercept. I think the intercept is this little guy. And the slope is this little guy. And kind of weird, but can I insert text box so I'm not here? So we want to interpret the slope first. In this case, the slope says for each unit increase in baths, increase in number of bathrooms, we expect the predicted price to increase, keep dropping that E, by 57,000. Oh, worth that reno, huh? $704.64. Right, that's how we interpret that slope. How do we interpret the intercept? Wow, typing under pressure. Not my forte, but I feel like I'm doing pretty good. The intercept is the predicted value of y when x is 0, right? So for a home with 0 baths, what do we predict the price to be? We predict the price to be $168,347. Seems kind of unreasonable, but okay. Maybe that's the lot value or something like that, right? The predicted selling price of a home with the 0 baths. I'm writing the 0 just to emphasize that the intercept is the predicted value of y when x is 0, right? And so with 0 bathrooms is $168,347.35. I'm going to leave it like that, right? But you have to be able to interpret the slope and interpret the intercept to be able to talk about what this model tells you, right? And then putting in the number of bathrooms, multiplying it by the slope, and finding the predicted selling price, that's all fine, right? And so predicted price of a home with 2 bathrooms, let's do that. What would you do? You've got your intercept and your bathrooms. You could grab the model from here, right? But I want to show you, so from the scatter plot, but because the scatter plot only really works for one predictor, I want to show you just in general how we're going to use this model. So then you need this output with the intercept and the baths. But then what you're going to do is you're going to reference these cells, of course, and you're going to say equals the intercept plus, and then I'll do brackets around the slope times 2, which is the number of bathrooms that we want. And you could put a 2 out here, right? Bathrooms 2 with X bathrooms. That's what I'm thinking. I think. Nice. All right, and then I can change the number of bathrooms. Go from there. Should be the same though. Okay, so we can do that for each individual variable, right? Looking back at the original data here for my reorganized, if I do square footage and selling price, I suspect that I'm going to also have a positive relationship, right? Because as the square footage increases, typically the selling price increases, same as we saw with bathrooms, right? Here we've got this kind of moderately strong linear relationship. Positive linear relationship. Again, as the number of bedrooms increases, we expect the selling price to increase as well. I'll call this tab simple bathrooms. Oops, that was supposed to be a little pink. There, bathrooms. And you can do the same for square footage in the bedrooms. I have this scatter plot, so I'm actually going to remove it. Okay, so we want a model that incorporates more information, right? That sounds valuable, right? But then what's going to happen is as we make adjustments, right, we'll see how they relate to each other. Okay? And so it's in that data tab, and it's the data analysis tool pack again. Regression again. And we can just give it more values of X, right? So instead of just the A column, I'm going to go in here and go like it. It's such a small data set that I'll just go by hand. So A1 to C27. There's still labels because I included the labels, mostly because it makes my output read a little bit cleaner, right? If I hadn't included the labels for the baths, it would have just said intercept and coefficient, I think. Play around with it, but which is not as easy to read. So that's why I like to include the labels, but then you have to tell it you have the labels. Nothing else is good. Nothing else is good. Ah. Okay. So now we've got similar looking output. A lot of that you're just gonna ignore, right? We haven't talked about the ANOVA, but what the ANOVA says is whether the model is doing anything, right? Is it predicting anything? Are these variables contributing to predicting the selling price? And so this p-value, that's of interest, but we haven't talked about that, so don't worry about that. One thing to note is that, where's my text box? Here. In multiple regression, which is what we're doing now, just multiple values of X, right? And so in multiple, it's a linear regression, but I like to just simplify it. We consider the adjusted R squared. So we had this R squared, which matched the output on our scatter plot earlier for the simple linear regression. But now we use the adjusted R squared. We consider the adjusted R squared instead of the regular R squared. And the reason for that is, do you expect your model to be better the more things that you incorporate, right? You do, right? But at some point, you're overfitting the model, right? And so what the adjusted R squared does is it penalizes you for adding too many things, right? Because the problem becomes, okay, our model is going to fit this data set, this exact data set, very, very well, right? If we add all these things and then we're able to capture everything in that data set, but then when we go to apply it to a new data set, which is the ultimate goal, is to be able to take this model that we built off of this data and say, hey, I'm going to use that for my new data. Cool. But then if we've overfitted, it's called, if we've overfitted the model based off of this sample, then it's not going to fit as well when we need the next sample. And so the adjusted R squared penalizes us for adding too many predictors to the model. I'll obviously post this spreadsheet with all my random notes in it after class. Usually I write on here. Okay, so for us, right, if we consider the R squared 0.55, right, that's better than the previous of 0.2 something. So we have a better model, right? The overall interpretation of the R squared, it's still a goodness of fit measure. It's still how well does your model fit your data, right? But we should be using the adjusted R squared just to kind of penalize ourselves for having too many things in our model, right? There's kind of a fine balance between a well-fitting model and just incorporating too much information. So now our multiple regression model looks the same, right? It's going to be, and how about, oh, why can't I? Oh, I see. Insert this box here. So our model is y hat is going to be the intercept plus the coefficient for the baths, oops, plus the coefficient for the square feet plus the coefficient for the beds. Inconsistent. Oh, it is consistent. Nice. Naming convention. All right. So we have these coefficients, B0, B1, B2, B3. What's one confusing thing? We look at the coefficient for the number of bathrooms now, and I'll highlight this and focus there. Saying that, okay, if the number of bathrooms, let's start with the intercept. If the number of bathrooms is 0, the square footage is 0, and the number of bedrooms is 0, then I predict the selling price to be negative 55.31. They'll pay you $5,000. Doesn't mean anything, right? That's just where our theoretical line is going to start, right? At 0, 0, 0. Yeah. So sometimes it means something, sometimes it doesn't mean anything. It's just an anchor.
I'll take a piece of land and $5,000.
Right? Yeah, make it work, right? Unfortunately, it's 0 square feet.
Oh.
Bummer, right? But yeah, I would take it too. I would just increase the square footage. Let's do like 10 square feet. It would still be negative. They'd still have to pay you. And so, right, so for the intercept, insert. Boop, boop, boop. There. When baths, square footage, and beds is 0, the predicted selling price is negative 553,101. So we can build this model, and maybe I'll do that in, I've got all these text boxes because I'm not very used to working with them. Put that there. Put her there. So my predicted price is negative 5531.01 plus. Oh, but it's a negative. That's confusing, right? You don't expect that to be negative. You do?
Sorry, your question answered.
Oh,
A negative, plus negative is not. I thought that's what you were asking.
like I've confused
No,
myself.
I don't think that's so bad.
What does that mean? It means that as you increase the number of bathrooms, the predicted selling price is going to decrease.
Well, yeah, based on the data that you provided, that's kind of what I was already.
Mm.
It didn't play much of a factor compared to the other ones, just based on the actual,
But what about this?
yeah, that's just factoring that alone.
Very good. My work here is done. 1386.21 times the baths, right? That's the only tricky one. Plus 6028 times the square footage plus 5479708 times the beds. Then you plug in the number of bathrooms the house has, the number of square feet it has, and the number of bedrooms, and then you get a predicted price. Now, I want to direct your attention to these p-values. I'll do the in green. It's kind of dark, I guess. You can still see it though. A p-value less than 0.05, right? Then we reject H naught. Well, what is H naught here? H naught is that the predictor does not contribute to the model, right? In kind of its bare bones sense, okay? And so here, does the intercept contribute to the model? In this case, it doesn't, right? It's got a huge p-value. The problem is we never remove the intercept because we need some anchor. It doesn't matter if it's contributing or not, right? But then when we look at the baths, what this p-value is saying is that if the null hypothesis is that the number of bathrooms does not contribute to the model, right? It makes no contribution, whereas the alternative is it is contributing to the model, right? Then the p-value here tells me that, okay, looks like the number of bathrooms is not contributing significantly to this model. The problem is, it assumes, like you're saying, it assumes that the other variables are in there, right? And so it hinges on all the other variables that are already in there. If we remove the number of bedrooms, we would probably find that the number of bathrooms, the predictor would be significant, right? And so we can talk about significant predictors, right? And in that sense, we mean we have enough evidence to reject H naught, that it's not contributing to the model, and say that it is. But it hinges on all these other variables that are also in the model, right? What's happening here is it's very likely that the number of bedrooms is kind of muscling the bathrooms out, right? As the number of bedrooms increases, traditionally we increase the number of bathrooms as well, right? And so then knowing the number of bedrooms kind of gives us all the information that we need. So one thing, kind of level up from where we're gonna go, but you could play around with a model that doesn't include the bathrooms, see how things change. I would suspect that then the square footage in the bedrooms would be even more significant, right? Because both of these are less than 0.05, the square footage in the bedrooms, Or another thing you could play around with is, what if you remove the number of bedrooms? Then I would expect that the bathrooms would become a significant predictor, right? And so we can talk about these p-values, but they assume that the other variables are in there. Okay? Same thing with the Bath's coefficient. So when we interpret the slope, that's easy enough, right? Because it's just the one coefficient on your one predictor, right? These are slopes, right? But we call them coefficients just because they're attached to each value of x, right? And so the Bath's coefficient tells me that as we increase, the general interpretation stays the same. So as we increase the number of bathrooms by 1 unit, right? For each unit increase in the number of bathrooms, we expect the selling price. Yeah, because I don't expect you to kind of have that takes, some sitting down and convincing yourself, right? A negative increase is a decrease. So I like to just say a negative increase because it doesn't trip me up. And it is more confusing, but at least you're welcome to say decrease. The problem is if you forget to drop the negative, right? A negative decrease is an increase. So that's the problem. So you have to be really careful, right? You'll have time to kind of sit down and think about what you're saying.
Is this the final project?
You'll do regression in the project, yeah. Mhm. But it's fun, right? Just predicting stuff, building models, predicting things. It's fun. So you need to be able to interpret the coefficients, and that's why we're doing it. We expect the selling price to, okay, I'll go for decrease by 138,621, right? Or increase by negative 138,621. And then the follow-up is assuming that all the other predictors are held constant, right? And so we only interpret one at a time. And so here's the follow-up. Besides that, it's been the same blurb that we used for the slope. And so assuming the other predictors are held constant. Okay. And so, right, we can do the square footage coefficient. I'll fill it in later. How about, I think you get the idea, right? For each unit increase in square footage, right, then we expect to see a $60.28 increase in the predicted selling price, and so on and so forth. Okay, nice. I'm just gonna take a look at, okay, part 3 in the question. Sorry, I'm not sharing that screen, but it's argued we do not need both number of baths and number of bedrooms. Okay. So develop an estimated regression equation that can be used to predict the selling price given square footage and the number of bedrooms. So we'll do that and see how those p-values change. I'll call this the full model. That's what we call the full model when we have all the predictors in there. Now, let's see here. All I'm gonna do is go back to the data analysis tool pack, and I'm gonna change my predictors to not include the bathrooms, I think it was, only the square foot and the bedrooms. And ta-da. One thing you'll see is that the adjusted R squared has increased, right? It's gotten closer to the regular R squared. That makes sense because I removed a predictor that wasn't contributing to the model, and so it's happier, right? And so here we've got 0.512. So if I'm comparing these two models, which is something that we do, right? If you're comparing these models, you would compare those adjusted R squareds and pick the one with the highest R squared. So when I worked at the market research firm, all day I would just build different models. I know. Isn't it so fun? But that is what you're doing, right? You're comparing all these R squareds, you're tweaking, you're looking at those P values, and you're looking at the individual predictors, and then eventually, right, to land on a model to present to your client, right, then you're going to pick the one with the highest R squared, unless there's a reason to pick a different one. In the full model, 49% versus 51%, right? Then, I don't know, you could argue it either way. That's the problem with stats. You could argue one way or another, whatever you want to do. What if this model, this 51%, now we're using the same variables, but what if one of the models was doing a slightly better job, right? 51% versus 49%, but it used very expensive to measure variables, right? Then that's not something that I would recommend. I would say, okay, if you want the best model, you would use these variables, and they would say, but that's really expensive to measure. Or you can use this one, it's not as good, right? But it's cheaper to measure. And so I would use this one ultimately, right? So it's kind of little game we like to play. Let's see here. Try to use a lighter color of green there. All right, just kind of focusing on these values. Okay, so we've got our adjusted R squared, it's slightly higher, right? Because we removed a variable. And if we look at the p-values, right, this is our model. The coefficients are our model, right? And that's how we're going to make predictions. But these p-values, the intercept is still not a significant predictor, but we just always keep it in there. And the square footage is definitely a significant predictor, and the number of bedrooms is also a significant predictor still, right? I think it'd be more interesting to remove the number of bedrooms, which was significant in the previous model, and then compare it. Let's do that. Baths removed. Because otherwise I'd have to list the other two. I'm lazy. Data analysis. Change these to be the bathrooms. Oh, and I guess yeah, what did I say I was gonna do? Baths and square footage, right? Whee! I'll label it right away. Beds removed. Someone submitted work to me the other day, and I did not know that you could change the color of the tabs. Did you guys know that?
Yeah.
Wow. I didn't. In my defense, though, I don't really tend to do analyses in Excel that often. Too much click, click, click. All right, so now we've got the number of beds removed. Uh-oh. Our R squared just tanked. It's not good. It's nice in the way that it eliminates having to choose between this model and another model, right? Already we say, scrap this model. Doesn't stand a chance. What's happening with the intercept? Yeah. But from what we've seen, right, it's just an anchor, and now it's having to kind of take over a lot of responsibility for this prediction, which doesn't really make sense. And that's why the adjusted R squared is lower. Interesting, interesting, interesting. The bathrooms is still not significant. That's weird. Oh, well. The intercept has kind of taken over, it looks like, and kind of shouldered a lot of that responsibility for the model. And then the square footage is really the only predictor that we would use here. Right. And so we're going to nix this one. It's no good. I'll go back to the baths removed. So far, that's our best model. Right. Okay. Then there was a with just the square footage. Oh, don't tempt me. All right, let's do it. Just the square footage, you say, huh? Oops. I'd be curious to know what it would look like. Square footage only. It's only one predictor, so you're allowed to use the regular R squared, but still not. I'm actually surprised that they're not the same. I have to think on that, I guess. That's weird. Everything is significant though. But I think, yeah, this one is our best model. What's another combination? You could go through all the possible combinations.
Beds
And
and baths. That's the last one, I think.
beds and
Or,
baths.
Yeah, you haven't done beds and
Something tells me the square footage. We need it. But it is worth playing around with, right? One of the problems becomes, what if you have more than 3 variables, right? What if you have a very basic data set with 10 variables? That's still a very small data set, right? But then you're trying to figure out what the combinations should be. And there's lots of different model selection techniques that you can use, right? One of the ways, and kind of my go-to way, because it's the most simple to explain mostly, is you fit the full model. So you include all your variables, right? And then you slowly pick out the non-significant or the insignificant predictors one at a time, right? And then you decrease it that way. And I don't think that Excel has a built-in model selection mechanism. I don't know, but I don't think so. Whereas if you're using, software like R or SPSS or something like that, then it has a built-in mechanism which will just run through and do it for you. Here you'd have to do it one at a time, which is kind of nice to see how things morph. But this is the best model we have fit so far. Whee! Ooh. Okay. So you could go through and you can play around with the others, but I had insert text box here. And suppose your house has 4 bedrooms and is 2650, so 2,650 square feet. What is the predicted selling price using the model? Predicted selling price, oops, price. Let's have some room here. We're just going to use the coefficients that are given, right? So the square footage is 2,650. And maybe what I'll do is bump this over here and say the beds. Oh, I'll do it in the order that the coefficients are. 2,650. And then the beds. 4 bedrooms. I guess it's a huge house. Put this down here. Because then if I reference these cells, of course, then I can change it and get different predictions. So I get my intercept plus the square footage times the square footage. And I don't think you need to, but I'm just going to wrap these up in brackets. Yeah, it's happy. And then wrap this one up in brackets times this. So now I have this model. The predicted selling price would be 369,646.91 pennies. We did it. Predicted with more than one predictor. Good job. Okay. There's something else I wanted to say. Move this over here. Can't think of it. Okay. Well, that's all I've got. Yes.
So how did you decide if this is the best one by looking at the adjusted R?
Yeah, just the adjusted R squared. That's our only gauge, and that's pretty common that you just use. Yeah, it should be as close to 1 as possible, but it'll always be less than this R squared, and so but in general, you just want it to be as close to 1 as possible. So what this R squared is telling us, I think that's what I wanted to say actually, is that 51.2% of the variability in the selling price is explained by incorporating these two predictors into our model, right? We know that there are other factors like maybe location and things like that that would also contribute to the selling price, right? And so those things we have not incorporated into our model, right? Whereas these, we've just got the square footage and the beds, and given that, it's taking up and it's accounting for about 51.2% of the selling prices. Nice, or the variability in the selling price. Nice. Okay. Any questions?
You're gonna assign us a final on Wednesday? Just right onto our Moodle page?
Yeah.
I know it-
Yeah.
so-
Oh, don't worry. Yeah, it'll be on Moodle, and I'll be here if you want to talk about it. But I'll also be on campus pretty much all the time. You know where to find me. If you know where Frank is, well, actually, yeah. He comes at the weirdest times. All right. I'm gonna stop sharing here and stop this recording. Where's my, how do I do that? Stop recording.